Hi everyone, in this tutorial we learn how to differentiate fractional powers of x. And to illustrate how it's done, in just a minute I'll be working through the three examples that we have here. But first, let me remind you of an important result. As soon as we're dealing with the nth root of x, we can rewrite this as a power of x. Indeed, the nth root of x is equal to x raised to the power of 1 over n. And in fact, we can push that result a little further and state that the nth root of x raised to a power m is equal to x raised to the power of m over n. And I'll go ahead and box that. Do make a note of it. What these results enable us to do is write any x which is expressed under a root as a power of x. So let's see how that's done with this first example. We have to differentiate f of x which equals to the cubic root of x. Well, first of all, using the result we've just seen, we can go ahead and state that f of x is equal to x raised to the power of 1 over 3. Indeed, since we're dealing with a cubic root, the number on the denominator of this fraction is a 3. Now that we've written f of x as a power of x, we can differentiate it using the power rule. And in doing so, we state that f dash of x, the derivative, is equal to 1/3 times x raised to the power of 1 over 3 minus 1. And now, since 1/3 minus 1 equals to negative 2/3, we can state that the derivative f dash of x is equal to 1 over 3, or 1/3, times x raised to the power of negative 2/3. And if all we have to do is differentiate the function, then we could stop there. That's a perfectly valid final result. But if ever we have to calculate or evaluate this derivative at a given value of x, then it can be quite useful to write this inside a root. Here's what I mean. We can go ahead and state that this is equal to 1 over 3 times 1 over x raised to the power of 2 over 3. Remember, this negative power tells us that we're dealing with the reciprocal. In other words, that we have to write it on the denominator. And now, to deal with this x to the power of 2/3, we use the second result we saw at the beginning here, and we read it from right to left. And in doing so, we can see that this is equal to 1 over 3 times 1 over the cubic root of x squared. Finally, we can state that the derivative f dash of x is equal to 1 over 3 times the cubic root of x squared. And that's the answer. Let's look at the second example. We have to differentiate f of x which is equal to 5 times the square root of x. Although we rarely write it, when we write the square root of x, there should actually be a little 2 at the top of the root here. In other words, we should really write f of x as f of x equals to 5 times the square root of x. Now, using the result we have at the top here, we can go ahead and write f of x as a power of x, and that would be f of x, which equals to 5 times x raised to the power of 1 over 2, or 1/2. And now, using the power rule, we can go ahead and state that the derivative f dash of x is equal to 5 times 1 over 2 times x raised to the power of 1 over 2 minus 1. And now, since 1 over 2 minus 1 is negative 1 over 2, and 5 times 1 over 2 is 5 over 2, we can state that f dash of x is equal to 5 over 2 times x raised to the power of negative 1 over 2. And that's the answer. But just as for the previous example, we could in fact go further and write our final answer in terms of the root. In other words, we could go ahead and state that this is equal to 5 over 2 times 1 over x raised to the power of a half, and since x to the power of a half is equal to the square root of x, this becomes 5 over 2 times 1 over the square root of x. Finally, multiplying these two fractions together, we can state that the derivative f dash of x is equal to 5 over 2 times the square root of x. And that's the answer. Before looking at the third and final example, let me point out that given that the square root of x is such a common function, it is worth knowing its derivative off by heart. And in fact, I'll write it in the upper left-hand corner here. Here it is. If f of x equals to the square root of x, then its derivative, f dash of x, will always be equal to 1 over 2 times the square root of x. And again, I'll go ahead and box that result. Do make a note of this. In fact, learn it off by heart. When studying calculus, you're going to differentiate the square root of x so many times, it's definitely worth knowing this result. That being said, let's work through this last example. We need to differentiate f of x, which is equal to 3 over the 5th root of x raised to the power of 4. Well, to get us started, let's rewrite this denominator as a power of x. For that, I use the second result that we have here. So that would be f of x, which equals to 3 over x raised to the power of 4 over 5. Now, given that this power of x is on the denominator, I can rewrite this using a negative power of x. In other words, I can go ahead and state that this is equal to 3 times x raised to the power of negative 4 over 5. And having rewritten f of x this way, we can now use the power rule to find its derivative. Indeed, we can state that f dash of x is equal to 3 times negative 4 over 5 times x raised to the power of negative 4 over 5 minus 1. Now, multiplying negative 4 over 5 by 3 and simplifying this exponent, we can state that the derivative, f dash of x, is equal to negative 12 over 5 times x raised to the power of negative 9 over 5. And once more, if differentiating is all we have to do, we could stop there. But we could also write our final answer inside a root and state that this is equal to negative 12 over 5 times 1 over x raised to the power of 9 over 5. And that leads us to negative 12 over 5 times 1 over the 5th root of x raised to the power of 9. Finally, multiplying these two fractions together, we can state that the derivative, f dash of x, is equal to negative 12 over 5 times the 5th root of x raised to the power of 9. And that's the final answer. And so that's how we can differentiate fractional powers of x, or the nth root of x, using the power rule. And that's it for this tutorial.